Okay, guys, welcome to another episode of Biostatistics. This hypothesis test, and we are using the T or the Z test. So let's look at this question. It says a researcher is interested in finding out whether the average life of females in the US is different from 75 years. For this, he takes a sample of 100 females with a sample mean of 76 and a sample standard deviation of 7. So the first one says state the null hypothesis and alternative hypothesis. And the B says at 95% confidence level, is there enough evidence to reject the null hypothesis? Good. So this is a nice question, mostly seen in hypothesis testing, and these are questions mostly seen under biostatistics. Okay, so let's watch here. So with this question, we have to know, are we going to use the Z test or the T test for this hypothesis test? For you to know which of these to use, you have to first consider the N. Consider the N. When N, according to hypothesis, we say when the sample size is greater than 30, we use the Z test. When the sample size is less than, so when N is greater than or equal to 30, we use the Z test. And when N is less than 30, we use the T test. So keep this one in mind. Okay, now let's state our null hypothesis and then our alternative hypothesis. So with how to state a null hypothesis and alternative hypothesis, we have to look every time there is the null hypothesis stands for the true, something which is there already. Then somebody will come in to claim that that thing is not there. So in this case, this is about a researcher. So he's claiming to find out whether the difference in the average ages of a female is different from 75. So it means that the null hypothesis will say that the average age of the females in US is equal to 75. So the null hypothesis, you say mu is equal to 75. Then under the alternative, this researcher will come in and say that no, it is different. So it is different means the mu is not equal to what? 75. The mu is not equal to what? 75. So this is the null hypothesis and this is the alternative hypothesis. Now, let's look at the critical region on which we can what? We got the second statement say, the second question say at 95% confidence level, is there enough evidence to reject the null hypothesis? So let's look at the critical region. The critical region of which we will reject our null hypothesis. Yes, and take note whether to know this is a two-tailed test. This is a two-tailed test because it can either increase or decrease. In my next video, I will explain how you know that whether this test is a two-tailed or one-tailed test. I will explain that to you. So now let's look at the critical region. So we draw our graph. So this is the critical region. I said we have a confidence level of 95, so which is 0.5. Then the left we just divide the left by what? 2. Then dividing the left, we have 0.02 over here and then 0.025. So this area is the rejection. This area is the what? Rejection. So now we have to go and look for the critical value from our Z table. So when you go to the table, I will explain that one also. When you go to the table, you look for 0.025 from the Z table. I don't have the table here, but I know the value. So from the table, our critical value becomes 1.96 on the left side and then 1.9 on the right side. So it means that if any value after solving, if any value falls within this, we are going to reject the null hypothesis. Now let's solve for our z value. So first, let's write the data given. We were given a sample mean of 76, and then n value of 100, and then a standard deviation of 7. And of course, the population mean is very important. We use the initial population mean. So this was the population mean. We use this. So the population mean here is 75. So now let's solve whether we are going to reject the null hypothesis or accept the null hypothesis. So z is equal to the sample mean minus the population all over s over n. Yes, so this is the formula we are going to find. So now substitution. So by substitution, we have 76 minus 75 all over 7 over root of 100. Now let's compute everything and let's find the answer. So the final answer, we are getting 1.43. And coming back to the graph, 1.43 will fall around this side. Yes, 1.43 will fall around this, which means that 1.43 is not in the rejection region. So now we say fail to reject. So in conclusion, fail to reject the null hypothesis. We fail to reject the null hypothesis. Yes, because there's no evidence to conclude that the average is different from the average is different from 75. So we fail to reject the null hypothesis. Thank you for watching. See you in my next video.